Hello everyone, welcome to IGBits. We train, you learn. All viewers, subscribers, listeners who are joined in today's class. For everyone, IGBits welcoming you all for happy learning. We shall continue our partial fractions learning in today's class. Without further delay, let's get into topic. Request to all viewers and listeners, if you have not subscribed the channel, please subscribe our YouTube channel. We have started uploading all learning videos on timely basis. Okay, a great help and great helping hand to extend who are actually in need would be a great the support to the system, right? So we are trying to put our efforts to build the knowledge base, and then I want you all help us to share the knowledge sharing sessions to the your friend circles, extend your support and be a helping hand to build a great knowledge competency teams. Thank you all for your wonderful support so far, whatever you did it, but I would like and wish it to be continue further. Thank you all. All right, so for the rule number 3 of partial fraction, before we getting into the rule number 3, we will actually cover few concepts as a prerequisite for this. So we all know that like there is a quadratic equation, and then how to find out the roots for the quadratic equation. Agree? So let me write down here. Let's say we have ax square plus bx plus c equal to 0. Let's say suppose this is like a generic quadratic equation. How do you find out the roots for these things? Right? How do you find them? Okay. So there's two ways to do that, right? We have a formula x equal to minus b plus or minus root of b square minus 4ac divided by 2a. Okay, this is one way. So you see that like why you are saying like plus or minus here? Because this is like a square term. The degree is 2. That means you should have a 2 roots for this equation. But the question is, what is the nature that the roots have? So to distinguish that portion, the b square minus 4ac. So do you know that what you can call it as this one? Discriminant. Discriminant. Okay, also known as a d. So this d value typically we have to calculate, right? If the d is less than 0, then you will get a imaginary roots. It means it is very difficult for you to find out the roots in normal way. That's what it means. Let's say suppose we have an equation like x square plus x plus 1 equal to 0. Find out the roots. I know there is a 2 roots, but what is the nature of the roots? That we don't know. So to in order to find that, you have to calculate b square is 4ac. So b means coefficient of x, a means coefficient of x square, and then c is a constant from this equation, right? Here a is equal to 1, b equal to 1, c equal to 1. Let's put here 1 square minus 4, 1 into 1, right? 1 into 1. So what's the value this one? 1 minus 4, so minus 3. Do you see? This is like a negative value, and hence roots would be maybe imaginary roots. So in this case, it's difficulty for you to find out the roots. So when you have this kind of scenario, how you are trying to find out a partial fraction for a given fraction? That is a condition that we were asking. Are you clear? So there is a two methods to find out, right? This is normally find out a roots for an alternative method. Let's say, for example, you have x squared minus 4x plus 4 equal to 0, right? So how do you find out the roots in the normal traditional method? You multiply factors of x square and then constant. What you will get it here? So 1 into 4, so 4, and then this 4 will be now find out a roots to match this one. When you say 1 into 4, what happened? 1 plus 4 is equal to 5. Otherwise 1 minus 4 is equal to 3. Things are not working. The next step is 2 into 2, right? 2 into 2 4, looks like 2 plus 2 also 4. If you put a minus these two, so minus into minus plus, the product gives a 4, and then add is minus. I think probably this would work, correct? No? So let me pick my color box. Okay, uh, where is my eraser? What I can see, this box, you can keep it, then I can try to find here. So x square, so minus 4x can be written as minus 2x, then for 4 equal to 0. So you can start it common. If you put x common, then within the x square, x is out, so left over is x. Here x is you are taken as a common, so minus 2 is left over. Similarly, you can take the 2 common, then this is x minus 2 equal to 0. So x minus 2, x minus 2, right? That means like the one more time you are common in both cases. X minus 2 you are taking out, then what is left over? X minus 2, right? So this is how you can find out the roots, right? These are the roots, are also factors. Agree? So factors for this equation. Similarly, for this we are not able to calculate, and hence we go for this one. So the same method can also be applied for here also to find out find out these roots, which we can study in detail in quadratic equations. But for now, I think this concept is sufficient to identify when we are going to apply rule number 3 for resolving partial fractions. Now let's look at what rule number 3 says. Partial fraction of f of x by g of x, where g of x contains irreducible factors. Okay, this is a condition. So we spoke about just now, right? When a given quadratic equation, if you are not able to find out factors, so what we are also termed as a irreducible factors, in that case, how do you gonna solve this problem, right? The rule number 3 is going to help you to identify this scenario and then give you a hint to resolve a given fraction into partial fractions. Let f of x by g of x be the proper fraction. Make a note, all the partial fractions we spoke about a proper fraction as a start point, right? You have to make sure the given equation is a proper fraction. From there you have to apply the rules. That is a the hint to solve the problems. Okay, to each non-repeated quadratic factor, so condition is you have a quadratic factor like a ax square plus bx plus c, where the factors cannot be made, so irreducible factors and a non-repeatable. In that scenario, for each term you have to use something like ax plus b by ax square plus bx plus c, where a capital uppercase a and b are the real numbers which are to be determined. That's the clue. So now the question is how you are going to identify them. Okay, let me put a few examples and then see how easy we can find out. Let's say we have an equation called 2x squared plus 1 divided by x cube minus 1. If you look at this example, the degree of numerator, the degree of numerator, right, is less than degree of denominator. You all agree? Right? Because this is a 2, this is 3. So that means this is a proper. This is a proper fraction. So that is a first condition. We are good with that. Right? Next one, what you are saying is like find out for the this is a g of x. Correct? For g of x, we have to find out a factors. X cube minus 1. This sounds to be a cube minus b cube. How do you solve this problem? Right? A minus b into a square minus ab plus b square. Is it correct? Or a plus b here. So now how do you solve this? How do you expand this? If you say x cube minus 1 can be written as x minus 1 into x square plus x plus 1. This is how you can write it. That's good. So this overall equation can be written as 2x square plus 1 divided by x cube minus 1 can be written as 2x square plus 1 divided by x minus 1 multiplied by x square plus x plus 1. See this, you can always think of when you have x cube, that means like the degree is 3, you should find out 3 roots for this, 3 terms. So if you look at here in the expansion, x minus 1 is the one factor and x square plus x plus 1 is the second factor. But this itself has a 2 values inside, isn't it? So you still need to find out factors for this. But question, will that be easy to do this? That is where rule number 3 concept comes into place. This is non-reducible, irreducible factors for this given quadratic equation, because b square minus 4ac if you calculate, which gives like a negative value, right? So in this case you have to apply this method. For this particular term you have to use ax plus b by ax square plus bx plus c, the term, to resolve this. This one is probably the same. This you can apply a rule number 1, this you can apply rule number 3 in order to get the partial fractions for the given proper fraction. Okay, let's see the few sums. Let's try out this solution for a given proper fraction. Let's resolve this into partial fractions. So just now you have seen this one, right? What is given is 2x square plus 1 divided by x cube minus 1. So based on the degree we can say this is a proper, and then we have to find out the factors for the denominator g of x function. So 2x square plus 1 divided by what is you say a cube minus b cube, so a minus b into x square plus x plus 1. When you see what we studied is this is one factor, this is another quadratic equation for which we cannot find out a factors because we cannot reduce this into factor form, straight method, right? In this case we have to use rule number 1 and 3 together, right? So how do you represent now? For this one, let's say a by x minus 1. plus. For this particular term, we can, the form is like this one, right? Bx plus c. Constants are like a different constant, so you should not use the same, like ax plus b here, because you already used it here. I'm using like a bx plus c. The term that you have to think of like one x term, one constant. That's how the partial fractions can be decomposed in using rule number 3. So divide by, for which x square plus x plus 1. So this is what the basically split for a given partial fraction using rule number 3. First thing is like we have to identify whether this needed rule number 1, rule number 2, rule number 3, either one of them, to split given fraction into partial fraction. I hope this concept is clear. The rest is simple. You can resolve this as easy. So now let's take only the numerator case. Your LCM is anyway same. You have to cross multiply and then equate the LHS and RHS for the numerators. So 2x square plus 1 is the numerator for the given, equal to cross multiply this one, a into x square plus x plus 1 plus this term, right, bx plus c multiplied by x minus 1. This is how you get it, a straightforward simple method. Now how do you identify constants a, b, c values in this case? This is a. You started actually substitute, right? By putting x equal to 1, this term can be eliminated. That's a case 1. Putting x equal to 1. So substitute x equal to 1 in both left hand side and right hand side. So let's put here, let me change my pen color. So for this, 2 of 1 whole square plus 1 equal to a into, right, 1 plus 1 plus 1. This is 0 because x minus 1, 1 minus 1, 0. So 2 plus 1, 3 equal to e of 3. What is a value? A value is 3 by 3, which is 1. Very good. So next one, let's compare both left hand side and right hand side coefficient of x square terms. Compare coefficients of x square in both LHS and RHS. Let's compare them. Here we have one x square term, the coefficient is like a 2. Okay, in the right hand side, this is one a x square, so a plus probably this one bx into x, bx squared, so right, this b term. So 2 equal to a plus b, then a is equal to 1, so 2 equal to 1 plus b, and hence b equal to 1. Right, you got a, you got b. Now you need to calculate a c value. How do you calculate c value? Maybe you can compare constants in both sides. So are you getting me? Right. So compare constant terms in both left hand side and then right hand side. Okay, so here constant is how much? C, that's one value, 1 equal to, in this a into 1a plus here c into 1 c, so minus c, basically this one, right? So let me, where is there? Minus c. So but we know a value is 1, so let's put here 1 equal to 1 minus c. So what's the c value now? C would be 0. Right. So now can you replace here? No. Okay, the final answer would be, do you have a different color here? Yeah. The final answer would be this much. So therefore A is equal to 1 by x minus 1, right, plus B. What is the B value? B is also 1 into x plus C value 0. So you will leave that option now, x by x square plus x plus 1 is the partial fraction for a given equation. Right? So this is the box plot. This is an answer that for a given fraction. Now we find out a constant. See, there is no hard and fast method, but you have to find out a clues for finding all constants. Either you are using a substituting method, or you can actually compare the coefficient of the constants or x square x terms. By some means you try to find out the values constants which we used for decomposing a small fractions called as a partial fractions to represent a given proper fraction. Okay, this is how the rule number 3 is going to help you. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Thank you all. We reached the end of the session today. We will see few more concepts in next session. Until then, have a good day. Bye bye.